This conference will now be recorded.
So, very good evening, students. We are continuing discussions on previous year's questions on the chapter ray optics. So, we have picked up questions from previous year's JEE papers. So, let us discuss today's problems. So, this particular problem is from IIT JEE paper 2010. So, let us read the problem first. So, a biconvex lens is formed with two thin plano-convex lenses. So you can see this figure. This is kind of a this is a biconvex lens, and this biconvex lens is actually formed with two thin plano-convex lens. One is this, and another one is like this. Okay, these are looking like little thicker, but they both have the same radius of curvature, same focal length. Okay, both are thin lenses, and if you just combine them, they will form like this. This is called biconvex lens, as shown in the figure here. Refractive index N of the first lens is given this. Suppose this is mu1 is 1.5, and that of the second lens, this is 1.2. Both curved surfaces are of the same radius of curvature, 14 centimeter. R is given, so 2f is equal to R. So f is R by 2. So we can find out the focal length for both of them, since the radius of curvature is given. Okay, so now for the biconvex lens, for an object of 40 centimeter, the image distance. So for an object which is at distance of 40 centimeter from this biconvex lens, where will be the image formed? I'll just make you clear again about this question. So there are two plano-convex lenses. One has refractive index 1.5, another one has refractive index 1.2, but anyway the focal lengths are same, or radius of curvatures are same for both the plano-convex lenses, and when they combine together to form a biconvex lens, you see something like this. Okay, so now if there is an object at 40 centimeter, okay, in front of the here, somewhere here, suppose this is 40 centimeter. Okay, so where the image of this object will form? Okay, that is the question. At what distance from the lens? That is the question. Now look, if I have to find out the image distance, we know how to find out. Image distance for lens formula, we know 1 by v minus 1 by u is equal to 1 by f. So what is this f? F is the focal length of the lens, v is the image distance, and this u is the object distance. So anyway, object distance is known. If we know the focal length, we can find out what is the image distance. But what is the focal length for this particular biconvex lens? We have to find out. See, focal length for this we have to find out, and we have to find out focal length for the other half. Okay, suppose this has focal length f1, this is focal length f2, and then since these two are combined, so you have to take the combination of these two focal length to find out the focal length of this particular lens. So we know focal length, formula for focal length for this f1 will be mu minus 1. Okay, mu minus 1 over f is equal to mu minus 1 whole into 1 by r1 minus 1 by r2. Okay, now look, this has r is the radius of curvature 1, radius of curvature for 1, and another one has radius of curvature at infinity. Okay, so for this case, look, this mu is 1.5 minus 1, this is fine. Okay, and this 1 by r is this, so this is r1 radius of curvature, and this has radius of curvature r2, suppose. Okay, so r2 is actually infinity for this, r2 is nearly equal to infinity, and r1 for this is 14 centimeter, right? 14 centimeter. So this is 1 over 14 minus 0. Okay, so this would give you 0.5 divided by 14. Okay, let it be like this. And for this, say 1 over f2, similarly it will be mu minus 1, and it is, see here, this is r2, so like you have, see, focal length 0 minus of, see, this is this way, right? So this is r1 in this case, so r1 has minus sign over here. Okay, so finally 1.2 minus 1 and whole into 1 over r1 means again it is 1 over 14. Okay, so ultimately you get for this also 0.2 by 14. Okay, so if you want to find out the focal length of both, you have to just take the combination of this. So combination is 1 over f is equal to 1 over f1 plus 1 over f2. Okay, so what was 1 over f1? 1 over f1 was 0.5 divided by 14, and this is 1 over, sorry, 0.2 over 14. So this will give you 0.7 over 14. Okay, so this is the focal length, sorry, 1 over focal length. So we can find out this as focal length as, we may need it 1 over f itself. So now see, the u was given as 40 centimeters, suppose. Okay, and this is also, this has centimeter inverse unit, and v we have to find out, we know the focal length, okay, of the combination. Okay, now if we apply length formula, 1 by v is equal to 1 by f plus 1 by u. So 1 by f was actually 1 by f is here 0.7 by 14, and this is minus 1 over 40. Okay, so we can do a little bit of simplification over here to find out this. Say this will be actually 1 over 7 over 140, and this is 1 over 40. Okay, so look, this LCM we have to find out. So let us take 5. this will be 28, this is 8, again 2 17, and this is 4, another 2 will come, so 7 and 2, so this is 10. Okay, so so 5 2's 10, 20, then 40, so it will be 280, so this is 14, and this will be 7, so 7 by 280 centimeter, so V will be actually 40 centimeter itself. Okay, so V will be 40 centimeter. Okay, so this option B will be the correct answer for this question. Okay, so this is the answer. So we'll go to the next question. And this will be actually in this side, okay, with positive sign. Since we have got positive sign, B is 40 centimeters, so the answer is this one. Option B will be the correct answer for this question. So what was the point over here? You need to note that the focal length of the combination you have to find out, because you have got this plano-convex length, sorry, biconvex length by combining two plano-convex lenses. So that was actually the point. Okay, now we'll go to the next question. Okay, so this question is also very interesting. So a biconvex lens of focal length 15 centimeter is in front of a plane mirror. Okay, the distance between the lens and the mirror is 10 centimeter. I'll just show you the figure over here. See, this is a lens, biconvex lens. It has focal length 15 centimeter. Okay, 15 centimeter, and this lens is actually placed in front of a mirror, and the distance between the mirror and the lens is 10 centimeter. Now the question is, a small object, say a point object, is kept 30 centimeter from the lens, 30 centimeter from the lens. Okay, 30 centimeter from the lens. Where will be the final image? Okay, I have not given you the options over here. Let me write down the options. So this is a virtual final images. So the final image is virtual and at a distance of 16 centimeter from the mirror. Virtual and at 16 centimeter from the mirror. At a distance. Okay, this is first option. Second option is that the image will be a real image, and it will form at a distance 20 centimeter from the mirror. So real and at a distance of 20 centimeter from the mirror. Okay, option C is virtual and at a distance. Okay, so real at a distance. Another option is real and at a distance distance of 16 centimeter from the mirror. Okay, and the last option is real and at a distance of of 20 centimeter from the mirror. Okay, so I'll just repeat the questions once again. So there is a biconvex lens which is placed at a distance 10 centimeter in front of a mirror, and it has focal length 15 centimeter. Okay, the distance between the lens and the mirror is 10 centimeter given. A small object is kept at 30 centimeter. Suppose this is the object and this distance is 30 centimeter from the lens. Where will be the final image? Okay, sorry, the final image is virtual at a distance of 16 centimeter from the mirror, or real at a distance of 20 centimeter from the mirror, or I think these options are, one should be virtual with this. Okay, so with 20 centimeter this is virtual and at a distance of 20 centimeter from the mirror, real and at a distance 16 centimeter from the mirror, real at a distance of 20 centimeter from the mirror. Okay, you might be a little bit confused. Let me take this figure to the next page in a clean place so that we can just do this here, do necessary calculations over here. Okay, so look here, it is given that the lens has focal length 15 centimeter and object is kept at minus 30 centimeter from the lens. Now forget about the mirror first. Just forget about the mirror. If suppose the mirror was not there, then where will be the image formed? So this much is actually 30 centimeter. Okay, 30 centimeter, right? And see, this is the focal length. So the object is kept where? The object is kept at 2f distance. See, this is also minus 15 centimeter. So the object is kept at 2f, right? 2f is 30 centimeter. That means where will be the image? Image will form actually at 2f itself. That means 30 centimeter plus. What does that mean? The image should have formed at 30 centimeter from the lens itself on the either side. Okay, this is also 30 centimeter suppose, right? Now look, the mirror is kept at 10 centimeter away from the lens. So what is this distance? This particular distance is, so this much distance is 20 centimeter. Okay, look here in this figure, I have drawn this as dotted line. What does this mean? This means that the ray, since this mirror is there, the ray is not going to penetrate it and come up to here and then form an image. Due to, like, that image is just formed by lens over here. This image is actually not the real image. In fact, there will be no image at this place. But if the mirror was not there, the image would have been formed here. Okay. So that's why this particular image I1 is virtual image, which is not there at all, and this image will act as virtual object. So I1 will act as a virtual object. In fact, there is no object or neither there is an image. But if the mirror was not there, there would have been an image due to this lens. Okay, so this will act as virtual object for the mirror, okay. Now if this act as a mirror, then see this will act as uh, this will act as object. So it would have formed another image which is at this place. So look, this much is 10 centimeter. So suppose this is 10 centimeter, another 10 centimeter. So it would have formed, as we know, mirror will actually, if this is the object distance d, the image distance also will be the same on either side. Okay, this will be image. Okay, this is O, this is I. So this is the property of plane mirror. It will form an image at the same distance on either side. Okay, so the image would have formed here. Okay, would have formed here if the lens was not there. Okay, just look here. See what happens. After refraction of the ray from object O, it get reflected again by the mirror. Okay, and that reflected ray would have met here at I3, but this due to this length, this reflected ray again gets refracted and form image finally at I2. I hope you are understanding my language. See what happens initially. Ray will go from object to the lens. It gets refracted, and it would have formed an image here at I1, which is 20 centimeter from the mirror. Okay, 20 centimeter from the mirror and 30 centimeter from the lens. Okay, since this mirror is here, so this refracted ray which is coming out from the lens will be getting reflected, and it would have formed an image at I3, which is at 20 centimeter from the mirror, which is at a distance 20 centimeter from the mirror. But because of the presence of this lens, this reflected ray also will get refracted, and instead of going and hitting here I3, it will meet at this I2 and form the point image here, final point image. So I2 will be actually the final image. I2 will be the final image. But how to find out that final distance of the final image? We have to now apply Lenz's formula. See, you have now virtual object for this lens, where at this I3. What is the distance? I3. See, this distance is 10 centimeter from the lens because it is 20 centimeter from the mirror. So now you have virtual object at 10 centimeter for the lens. Okay, and you have focal length for the lens is again 15 centimeter, and you have to find out what is the image. Okay, what is the image? So we know from lens formula we can write 1 by f is equal to 1 by v minus 1 by u. So from here we can find out 1 by v is equal to 1 by f plus 1 by u. So 1 by v, let's see. So this is 1 by 15 and this is minus 1 by 10. Okay, so this will be, okay, let us do this LCM. So 1 over 15 minus 1 over 10. So this will be 30. 2 minus 3. Okay, 2 minus 3, that means 1 over 2, and this is 30. 10 centimeter, all right. 30, that is No, I'm sorry. I think there is some mistake I have done. Let me just check where exactly I have done the mistake. I'm sorry. Actually, this is okay. So since this is a virtual object, so actually okay. So I have done a mistake over here in the sign convention itself. So 1 by f is equal to 1 by v minus 1 by u. So this is fine. So here this will be positive. Okay. So 10 centimeter. This is a positive. So you will get here 3 plus 2 or 2 plus 3. Anyway, this is 30. So 5 by 30 means 1 over 6. That means your v will be 6 centimeter from here. Okay, I'll just write it here. So v will be 6 centimeter. Okay, so look here, the final image is I2, and that will be formed at 6 centimeter from the lens. This is from the lens, 6 centimeter from the lens. Okay, 6 centimeter from the lens. So it will be at 16 centimeter from the mirror then. Okay, so what will be the answer? The final image distance will be 16 centimeter from the mirror, but the image will be actually real image. Okay, so the image will be a real image. So real image at a distance of 16 centimeter from the mirror. This C, option C will be correct here. Okay, so the final image is this I2, and this I2 is actually from, this is 6 centimeter from the lens. So from mirror it will be 16 centimeter away, and it will be a real image. Okay, so I hope you have understood this uh, solution and how to think it. All right, we'll go to the next question. So we have actually picked up uh, most of the questions from mirror and lenses today. Okay, so the previous question, this question was actually from 2010 IIT JEE 2010. This problem was again from IIT JEE 2010. Okay, now we have this question from 2000 2012, I guess. This is also from 2012. Okay, so a short linear object of length b lies along the axis of a concave mirror of focal length f at a distance u from the pole. Okay, pole of the mirror. The size of the image is approximately equal to. So here uh, the options are given like this. The size of the image is given as b u minus f divided by f whole to the power half. Option B is b f divided by u minus f whole to the power half again. Option C here, b into u minus f divided by f, and option D says this is image size will be f divided by u minus f whole square. Okay, this is the question. So the question is, there is a concave mirror. Okay, so anyway, we know the equation for mirror. Okay, so what is the mirror equation? 1 by v plus 1 by u is equal to 1 by f. Here there will be plus sign. Okay, so this is the mirror general formula for mirror. Okay, look what we can do now here. Just let me get a page over here, an open page over here. Yes, I have got a page. So we know mirror equation 1 by v plus 1 by u is equal to 1 by f. Now if I take partial derivative from both sides, see in this case you know this f is constant for a mirror, constant. Even for a length, also for a particular length it will be constant. So if I just take partial derivative, just like what you have done for calculation of percentage error, and this will be 0. Look, this says 1 over v square. If I just multiply u on, like u in the numerator on both sides, so it will be u square minus 1. Here there will be dv obviously, and this will be only du. Okay, I'll just write it. So it will be u square by v square into dv is equal to du. Look, if I say this equation is number 1, okay, equation number, let me tell this as equation number 1 and this as equation number 2. Okay, so look, what is this? This is the image size, and what is the du? This is actually object size, which is actually given as b, Now look, if I go with the mirror equation 1, see from 1, equation 1, what we can write? 1 by v is equal to, sorry, plus 1 by u is equal to 1 by f. This I can write u by v plus 1, sorry, this is 1 over f, is equal to 1 over f. Okay, so from here actually we can write u by v to be 1 by f minus 1. That means what? If we just take minus, okay, so it is actually 1 minus f divided by f, right? If we take common, this minus common, then f minus 1 divided by f. This is what we get, okay, with the minus sign common over here. All right, so now if we take the square of it, then what we get? F minus 1 divided by, oh, I am sorry, there will be u multiplied here also, u by f, so u minus f. So this will be f minus u. Okay, if required. Okay, so f minus u whole square, and this is divided by f square. Okay, I'll just take help of this particular space. Let me just now ignore this equation this much. I'm just writing it down directly. This part I'll write it down. So we have got u square by v square into dv is equal to du. So now we are just finding out what is this in terms of u and f. Okay, so we have already got this. We will just put it, just put, so putting u square by v square, suppose this equation is 3, from 3, okay, putting this into equation 2 from 3. Okay, so what we'll get, look, we'll write here. So u square by v square, we have got f minus u by f whole square. Okay, this into dv. Okay, this is dv, which is equal to du. Okay, now dv we have to find out, isn't it? So dv will be, so this du we have already written, this will be actually b. So b into f by f minus u whole square, or other way, u minus f also we can write. Let us see what are the options. See f, okay, so this is the only option which has square. Let me see. Okay, yes, we have got this. Okay, so look, we have got this finally. So b into f by f minus u, or since it is inside the square whole square, u minus f also fine. Okay, so this can be even written as b f by f minus u. This also is true, because if I take minus common and square of it, that will give you plus. Okay, so that's how this option is actually correct option here. Option D is correct. Okay, now we'll move on to the fourth problem. So this problem is also again interesting problem. Let us first let us first read the question and then write down the options also. So the question says two beams of red and violet colors are made to pass separately through a prism of angle of prism 60. That means A is 60-degree angle of prism. In the position of minimum deviation, what is the angle of refraction? Okay, so the options are angle. So at the minimum angle of deviation, the angle of refraction will be 30 degree for both the colors. First option. Second option is greater for the violet color. Okay, so greater for the violet color. Okay, option C is greater for the red color, greater for the red color. Okay, and option D is equal equal but not 30 degree for not 30 degree for both the colors. Okay, all right, let us see what happens at the minimum angle of deviation. Okay, let me just take this figure to some other place maybe. Okay, let's go to this place. See, at minimum angle of deviation, angle of deviation is delta is equal to 1 plus, sorry, I plus E, angle of incidence, angle of emergence, minus A. Okay, so kind of this. And also another point is when the this is minimum, what happens at this minimum, at delta minimum, the angle of refraction, see inside, see R1 and R2, so this will be equal. Okay, this will be equal. All right, this will be equal. And we know that R1 plus R2 is generally 2 into A. Sorry, R1 plus R2 is equal to A. Okay, so in this case, look, A is 60 degree. At minimum angle of deviation, R1 and R2, that means this angle, refracted ray, this ray will be parallel to the base. See, this is the base, and this is the refracted ray inside. So this will be actually, these two will be parallel. So this ray inside will be parallel to each other, and at minimum angle of deviation, this will be equal to this. Okay, angle of incidence and angle of emergence will be the same. Okay, that will be the same. All right, so what I'm trying to say is that at the minimum angle of deviation, it doesn't matter what color it may be, this angle R1 and R2 will be equal. So for that case, see 2R, 2 angle of refraction 2R, see this will be A. Okay, A means 60 degree given, so R will be 60 by 2, that is 30 degree for both. Okay, so at minimum angle of deviation, uh, this angle of refraction does not change. Okay, for different colors, it is not different for different colors, because at minimum angle of deviation, whatever color it may be, R1 will be equal to R2. So that is the reason. So the first option will be the correct in this case. So 30 degree for both the colors. Okay, it doesn't matter what color it may be, both R1 and R2 will be equal, or the ray inside the prism will be parallel to the base. So because of that, at minimum angle of deviation, every color will have the same deviation, sorry, same angle of refraction. Okay, all right, we'll have another question. This probably the last question for today. So this is, see, this is again related to the minimum angle of deviation. Okay, so the graph between angle of deviation delta and angle of incidence for a triangular prism. So there are 4 figures. You have to find out which one is the correct figure for this. Like, what is the correct variation of angle of deviation with the incidence, angle of incidence for a prism? You know, you might be familiar with the figure. Look this figure. So this is actually the variation of angle of deviation with respect to angle of incidence. Okay, so initially angle of deviation will decrease. Okay, angle of deviation will decrease with increase in angle of incidence. Then it will reach to a minimum value, which is delta minimum here, or this is called minimum angle of deviation, and you can see that angle of emergence and angle of incidence will be the same at this place. Look here, there are two I, that means this is I1 and this is I2. this represents at any angle of deviation there are two angles, the I1 and I2. That means the angle of deviation and angle of incidence are different. But this I1 and I2 they merges here. That means at minimum angle of deviation, the angle of incidence and angle of emergence will be same. That is what is the meaning here. Now, if you increase I again, that means the angle of incidence. If you increase again, the minimum angle of deviation will actually now start start increasing from here, and it will be kind of this curve. Okay, so kind of this parabolic curve. Okay, so this will be clearly, so this is the point here. Okay, so this is how so you have to remember the figure. Okay, so the variation of angle of deviation with angle of incidence for an image sorry for a triangular prism is varying like this. Okay, not like this. This is not the one. So you should not be getting confused, because angle of deviation has to be minimum at certain point, and that's where we will be using the uh, prism for uh, dispersion or any other applications. Okay, so while working with prism we have to first find out what is the minimum angle of deviation. Okay, so minimum angle of deviation and corresponding that angle of incidence is important. Okay, to carry out any experiment with prism. So that's why we should remember the variation of angle of deviation with angle of incidence for a triangular prism. Okay, so with this we'll stop it here for today, and next day we'll take up many more questions on this topic. Okay, so thank you for your presence. Bye for today.